In this video, I want to give a high-level explanation of how a man-in-the-middle attack actually works. And in the next video, I want to give a practical demonstration with code for you to try out. If you already understand the theory, then skip this video and go straight to the next video where I show you how to do ARP poisoning and DNS poisoning. This video is actually episode 1 on public key infrastructure and TLS certificates. But before I can explain how any of that works and how things like TLS certificates improve the security of your web applications, I need to demonstrate what you are actually trying to defend against. That's why episode 1 and episode 2 will be about man-in-the-middle attacks. My goal is for people with minimal technical knowledge to gain practical security knowledge that they can apply for their software development. I will provide practical examples in various forms such as diagrams, code, and simple mathematical formulas to accommodate various learning styles. These are the episodes that I have tentatively planned, but they are subject to change based on questions and feedback that I get as we progress through the series. So let's get started. Let's define man-in-the-middle attack. Here's a definition that I got from Wikipedia. In cryptography and computer security, a man-in-the-middle attack or an on-path attack is a cyber attack where the attacker secretly relays and possibly alters the communications between two parties who believe that they are directly communicating with each other, as the attacker has inserted themselves between the two user parties. Now, to make this definition a little bit more understandable, let me give you an analogy from the physical world. Imagine a person named Alice wants to use the postal service to deliver a letter to Bob. In this situation, a man-in-the-middle attack could be a criminal who secretly gets a hold of the letter while it is in transit to Bob. While the criminal is in possession of the letter, he can do quite a few things. The criminal can open the letter and read it himself. In cybersecurity, we call this violating confidentiality, because the criminal is reading information he is not authorized to read. The criminal can also alter the contents of the letter. We call this violating the integrity of the letter's content. The criminal can also pretend to be Alice and create an entirely different letter. The criminal does this by copying Alice's writing style and copying Alice's signature. We call this type of forgery violating authenticity, because the letter that the criminal fabricates was not authentically created by the original author, which is Alice. So that's how a man-in-the-middle attack can happen in the physical world. A man-in-the-middle attack can also occur on the internet. The attack happens while the information travels from the sender to the recipient. Let's say this diagram here reflects the internet. Now, it might seem complicated, but it's actually an oversimplification of how the internet really works. To start my explanation, let me simplify this diagram even further. Let's just focus on this one component here to reflect a typical Wi-Fi setup in a building, and let's assume the Wi-Fi network does not yet have internet access. This typical Wi-Fi setup could be your home network, it could be your office network, it could be the Wi-Fi at a coffee shop, or it could be the Wi-Fi in any other building. Computers in a building connect to each other through a router to form a local area network. Sometimes people call the local area network by the acronym LAN or pronounced LAN, or they might say local network, or they might even say private network. The purpose of the router is to broker traffic or relay information between each computer on the local network. When a computer is in a local network, the router assigns each computer a unique Internet Protocol address, also known as an IP address. The IP address in a local network is kind of like the room number in a very large office building. The CEO could be in room 100, the VP could be in room 101, the manager could be in room 102, and so on and so on. But in the case of a local network, instead of room numbers, we use IP addresses. A common convention for IP address is to use 4 numbers separated by 3 periods, and we call this format the IPv4 format. So if this computer wants to talk to this computer, This computer would tell the router, I am looking for the computer at the IP address of 192.168.0.101. And the router will relay the traffic accordingly. So that's how computers with the help of the router find each other on a local network. But what if a computer wants to talk to another computer in a completely different building in another part of the world? In this situation, a computer makes a request to the router makes a request to the modem connects to the internet, and the internet tries to find the correct modem that is somewhere else on the internet. The internet is a complex network made up of satellites, cell towers, and many other telecom technologies, which I won't get into in this video. But to visualize what the journey of the data could be, let's expand this diagram again. The data could travel a path similar to the path depicted in the red lines. This is still an oversimplification, but hopefully it gets the point across that a lot of parties could be involved in delivering the data from the left to the right. A man-in-the-middle attack can happen at any point where I've drawn a red line. Some unauthorized computer can insert itself between any two devices and start performing unauthorized activities. Let me pick a random local network to explain the high-level steps for performing a man-in-the-middle attack. I'm going to randomly pick this network here in the bottom left. Whatever I describe next could just as easily happen in any other local network in this diagram of the internet. So let's just take the bottom left network and let's simplify it to just this. Let's say on the left is the Wi-Fi network at a coffee shop. There are two customers connected to the Wi-Fi of this coffee shop. The router in the coffee shop assigns the IP of 192.168.0.101 to the computer of one customer and 192.168.0.102 to the computer of another customer. The Wi-Fi router itself has the IP of 192.168.0.1, and we often call the router's IP address the gateway address. Let's also assume that the coffee shop owner bought a special type of router that also includes a modem. It's very common to have a router that also has the capabilities of a modem. And it is the modem that connects to the internet and gives all the computers on the local network the ability to interact with the internet. So now, looking to the right side, we have YouTube's office building. For simplicity, let's just say YouTube's office has the same local network setup as our coffee shop, except YouTube has only one computer to serve up the YouTube website. The modem in YouTube's office building has a public IP address. For now, I will just pretend YouTube's public IP is 57.22.23.5. I just made up this IP for the purposes of this video. It's not the real YouTube IP. But before I continue, I should explain what is a public IP address. Let's go back to this earlier slide. Notice that each office building connected to the internet have their own IP address as well. When a modem connects to an internet service provider, the internet service provider assigns the modem a unique IP address to identify itself on the internet. This is what we call the public IP address. So this means we have two different types of IP addresses, the public IP address and the local network IP address. The public IP tells computers how to find a modem on the internet, while the local IP tells computers how to find another computer on the local network. It's like the difference between an international address and a room number. Public IP is like the international address where you state the country, city, and street, and the local IP is like the room number. When a computer in the coffee shop wants to load up the YouTube website, the computer in the coffee shop needs to tell the modem in the coffee shop to find the modem with a public IP of 57.22.23.5. So someone might ask, when I want to watch YouTube videos in my web browser, how come I have never had to type an IP address like 57.22.23.5? How come I can just type youtube.com into my web browser to see the YouTube website? To answer this question, I need to explain the concept of domain name system, or DNS. A domain name system is a way to translate a domain name like youtube.com into an IP address. For simplicity, you can think of DNS as an address book. In fact, you can think of DNS as a simple text file that keeps track of domains and IP addresses. The text file will have one column with domain names and another column with IP addresses. When you want to know the IP address of youtube.com, just open up the text file, find the line with youtube.com, and read the IP address right beside it. The file to manage DNS can reside on any computer or any device that takes part in delivering data from sender to recipient. It's similar to the postal service, where the post office, the airplane pilot, the truck driver, the door-to-door delivery person, and anyone else taking part in the delivery of the mail, every single one of these individuals each have their own copy of a map. But if any one of these individuals taking part in the mail delivery is using a map that is out of date, then the mail will not be delivered to the right place. In the case of DNS, if any device helping to deliver web traffic has outdated DNS records or corrupt DNS records, then traffic will fail to reach the intended recipient. And this becomes important later on when I talk about DNS poisoning or DNS spoofing. But for now, that's our setup on how a computer on a coffee shop Wi-Fi network will connect to a computer in the YouTube office to load up the YouTube website. A computer asks for youtube.com, youtube.com gets translated to an IP address, and all the routers, modems, and ISPs will try to connect these two computers via IP address. Alright, so how exactly does a man-in-the-middle attack occur? Let's say the computer with the IP ending in 102 wants to observe the traffic between the 101 computer and the router. Then 102 needs to insert itself in the middle over here to perform the man-in-the-middle attack. And now, any traffic between 101 and the router and the rest of the world must go through 102. When 102 is in the middle, 102 can do any one or combination of these three things. 102 can read the data traffic between 101 and the router. As a reminder, we call this breaching confidentiality. 102 can also alter the contents of the traffic, and we call this breaching integrity. 102 can also pretend to be a computer that it is not, and we call this breaching authenticity. I should elaborate a bit more on this concept of authenticity. The router is always on standby waiting for any requests from computers on the network. So let's say 101 suddenly wants to open up the login page for youtube.com. So 101 will ask the router, "Hey router, can you get me the login page for youtube.com?" But instead of the router responding, the 102 computer will say, "Hey 101, I'm the router, and let me download the login page from youtube.com and give that to you." 102 could make a completely fake login page with viruses, malware, and a whole bunch of inappropriate content, and then deliver this fictitious web page to 101, and then claim that it came from YouTube. And if 101 doesn't have the tools to verify the authenticity of 102's claim, then 101 just accepted dangerous information. These three aspects of confidentiality, integrity, and authenticity are often what man-in-the-middle attackers try to exploit. And in later episodes, I will explain how to protect these three things with things like encryption, TLS certificates, and the broader public key infrastructure. Alright, so that's enough theory. We just summarized most of the networking fundamentals and technology definitions that will let us understand the contents of upcoming episodes. So click to the next video where I show you step by step how easy it is to start performing your own man-in-the-middle attacks by using ARP poisoning and DNS poisoning.